Okay, so let's apply all the concepts that we learned in the previous video using this example. So we have here that line L is parallel to line M, and the measure of angle 1 is equal to the measure of angle 7. Let's find the measure of angle 2, the measure of angle 5, the measure of angle 4, and the measure of angle 8. Okay, but before that, let's illustrate first our given. So let's suppose that this would be line L, and let's suppose that this is line M. And suppose as well that this is line P, and P is the transversal of line L parallel to line M. And let's name our angles. Let's say this one is angle 1, angle 2, angle 3, angle 4, angle 5, angle 6, 7, and 8. Okay, let's have our solution. For letter A, we know that what is unknown is the measure of angle 2. Okay? Given that the measure of angle 1 is equal to 117. So basically before we can look for the measure of angle 2, I'm going to define first a new concept, which is linear pair. Okay, let's define what a linear pair is. A linear pair is an adjacent supplementary angle. Okay, so based on this definition, since a linear pair is an adjacent angle, we know that angle 1 and angle 2 must share a common side. That is what we discussed in the previous chapter. And since a linear pair is also a supplementary angle, then we say that their sum must be equal to 180. Okay, so we say that angle 1 and angle 2 are linear pairs. So I'm going to show first the relationship. The technique here is that you know how to distinguish the relationships between the pairs of angles. So we know that angle 1 and angle 2 are linear pairs, and based on the definition, their sum must be equal to 180, which is, we know that the measure of angle 1 is 117. So by substitution, that's 117 plus the measure of angle 2, which is equal to 180, and adding both sides by, or subtracting both sides by 117, we know that the measure of angle 2 is 180 minus 117. Therefore, the measure of angle 2 here is equal to 63. Okay? Now, for letter B, we know that from the given figure, we can say that angle 1 and angle 5 are corresponding angles. So angle 1 and angle 5 are corresponding angles. So if they are corresponding angles, we know that angle 1 is congruent to angle 5. That is the postulate that we discussed in the previous video. We know that if two lines are cut by a transversal, then the corresponding angles are congruent. And because we know that they are already congruent, these two angles are already congruent, therefore we can say that the measure of angle 1 is equal to the measure of angle 5. And since the measure of angle 1 is 117, so by substitution we know that the measure of angle 5 is also 117. And that's the answer. For letter C, from the given figure, we know that angle 2 and angle 4 are vertical angles. So we say that angle 2 and angle 4 are vertical angles. And since angle 2 and angle 4 are vertical angles, then the measure of angle 2, rather, angle 2 is congruent to angle 4. And by the definition of congruent angles, the measure of angle 2 is equal to the measure of angle 4. So you might be wondering why these two angles are vertical angles. In the previous chapter, we already discussed that whenever we have two vertical angles or vertical angles, a pair of vertical angles, then we can say that they are congruent. Okay, so we already have a measure for angle 2, and by substitution, we know that angle 4, the measure of angle 4 is also 63. And finally, for letter D, the relationship between, notice that angle 4 and angle 8 are corresponding angles. So since they are corresponding angles, angle 4 and angle 8 are corresponding angles. Okay, then therefore we can say that angle 4 is congruent to angle 8. And by the definition of congruent angles, the measure of angle 4 is equal to the measure of angle 8. Okay, and again by substitution, we know that angle 4 is 63, so therefore the measure of angle 8 is also 63, and we are done. Okay, now so we're going to use those concepts, particularly the postulate that we had in the previous video, to prove these theorems on parallel lines and special angles. So the first theorem that we have to bear in mind is that if two parallel lines are cut by a transversal, then the pairs of alternate interior angles are congruent. So we're going to prove that using the corresponding angles postulate. Okay, so first let's illustrate. Let's have a line or two lines which should be parallel. Let's name this one as line A and line B, and let's have our transversal. Let's name this one as line C, and then let's name the angles as angle 1, angle 2, angle 3, 4, we have 5, 6, 7, and 8. Now, so given that line A is parallel to line B, cut by line C, which is our transversal. Let's prove that angle 4 is congruent to angle 5. Okay? And we know that angle 4 and angle 5 are alternate interior angles, as well as angle 3 and angle 6. But in this video, we'll just show that angle 4 is congruent to angle 5, since angle 3 and angle 6 are also alternate interior angles. So let's have our proof. Let's form our two-column proof. So number one, we always start with our given. These are our statements, and these are our reasons. Okay, for number one, we know that line A is parallel to line B cut by line C. And the reason here is always given. Okay. For number 2, now, since line A, okay, since line A is parallel to line B and cut by transversal C, we can infer that angle 2 is congruent to angle 5, since angle 2 and angle 5 are corresponding angles. Okay? So angle 2 is congruent to angle 5. This is if two lines are two parallel lines. To be specific, if two parallel lines are cut by a transversal, okay, then we know that angle 2 and angle 5 are corresponding angles. Then the corresponding angles are congruent. Okay? Now, what else can we infer from our given figure? Okay, so since we are trying to prove that angle 4 is congruent to angle 5, and we already have shown that angle 2 is congruent to angle 5, we can also say that angle 2 is congruent to angle 4. Okay? So the third statement would be angle 2 is congruent to angle 4. And the reason to that is we know that angle 2 is angle 2 and angle 4 are vertical angles. So therefore, this is vertical angles theorem. Okay? Vertical angles theorem. Okay? For simplicity, let's just name it this one as VAT. And you can see already that angle 4 here can already conclude that angle 4 is congruent to angle 5. And the reason to that is the transitive property. Okay? Transitive property of congruency. And that ends our proof. So QED. Okay, do not forget to include the word QED because that means that we are already ending our proof. Okay? Next. We also have a theorem for alternate exterior angles. So, if two parallel lines are cut by a transversal, then the pairs of alternate exterior angles are congruent. Now, I will no longer prove this one because the proof is the same as the proof that we had in the previous theorem, which is if two parallel lines are cut by a transversal, then the pairs of alternate interior angles are congruent. So I'll just put it here in the previous figure. I'm going to use as well the same figure. Line A is parallel to line B, cut by C, which is our transversal. Okay, then angle 1 is congruent to angle 8, which is they are alternate interior angles, as well as angle 2 is congruent to angle 7. Okay, that's it. So if you want to try to prove this one, just follow this pattern and just replace the angles. Okay, next we have, if two parallel lines are cut by a transversal, then the pairs of interior angles on the same side of the transversal are supplementary. So we are talking about interior angles on the same side of the transversal. And let's prove that they are supplementary. So again, let's illustrate that first using our figure. And let's name this one as angle A, this one with angle B, line A rather, and this one is line B, and this one is line C as our transversal. And let's name the angles as angle 1, 2, 3, 4, 5, 6, 7, 8. Given, let's write our given again. Line A is parallel to line B cut by C. Okay, let's prove. Let's prove that angle 3 and angle 6 are supplementary. Okay, okay, let's have our proof. So again, let's have our statements and the reasons. For number 1, it has to always be the given. So line A is parallel to line B cut by C. And the reason is given. Okay, so number 2, what can we infer from knowing that line A is parallel to line B cut by transversal C? We can say that we can see here that angle 2 and angle 6 are corresponding angles. Okay, so if they are corresponding angles, then we know that they are congruent. So angle 2 is congruent to angle 6. And the reason is, if two parallel lines are cut by a transversal, okay, then the corresponding angles are congruent. Okay, next, from the figure as well, we can see here that angle 2 is congruent to angle 4. Okay, angle 2 is congruent to angle 4 because angle 2 and angle 4 are vertical angles. So let's write it here. Angle 2 is congruent to angle 4. Okay, this is vertical angles theorem. Okay, now, so we can already conclude here that since angle 2 is congruent to angle 6 and angle 2 is congruent to angle 4, that angle 4 is congruent to angle 6. That is by transitive property of congruency. Transitive property of congruency. And since angle 4 is congruent to angle 6, then we can say that the measure of angle 4 is equal to the measure of angle 6. The reason is definition of congruent angles. Okay, so let's continue. So from the given figure, we can say that angle 3 and angle 4 form a linear pair. Okay, so let's write it down. Angle 3 and angle 4 form a linear pair. And the reason for that is figure. We saw that in the figure. And we basically know the definition of linear pair. So therefore, we can conclude that the measure of angle 3 plus the measure of angle 4 is equal to 180. And this is actually definition of linear pair. Okay? Now, so we can see from the statement 5 that the measure of angle 4 is equal to the measure of angle 6. So by substitution, we can say that the measure of angle 3 plus the measure of angle 6 is equal to 180. This is by substitution. Okay? Substitution or replacement. Now, so we already have shown that the measure of angle 3 plus the measure of angle 6 is equal to 180. And since their sum is already 180, then we can conclude that angle 3 and angle 6 are supplementary. Okay? The reason is definition of supplementary angles. Okay? Supplementary angles. And we are done. Next theorem. So if two parallel lines are cut by a transversal, then the pairs of exterior angles on the same side of transversal are supplementary. So again, the proof of this theorem is similar to the proof of the previously proved theorem. So if you wanted to prove this theorem, you just follow the statements and reasons that were provided previously and change the angles. Okay, but in this case I will just write here in the previous figure, since line A is parallel to line B cut by line C, then angle 2 and angle 7 are supplementary. That is, the measure of angle 2 plus the measure of angle 7 is equal to 180. Okay? So we're going to use these theorems in our two examples, which will be shown in the next video.